All right, hey everybody, thanks for coming back. So let's continue where we left off. Where am I? Okay, so we're going to open up our project here. Okay, about that. Okay, so last time I have a triangle and I have the ability to move forward, I can move back, I can move left, and move right, and that's it. All right. So today, by the end, hopefully what I would like to do is have full 6 degrees of motion with my camera, so I can move it all around. I can look up, I can look down, look all around, and basically view that triangle from any angle I would like. So first, actually, you know what I'm going to do first? Looking at my math class here, I'm going to change my matrix 4 to actually take in use a constructor. And that's just going to make it easier to make matrices. So I'm going to have a blank constructor that does nothing. And then I'm going to have one that takes in a value. And then that's going to be the main diagonal for my matrix. So basically, I'm just going to take that here. Oops. And then basically everything along the main diagonal is going to be that value. And everything else is going to be zeros. And then I believe I can get rid of all this extra stuff here. All right, so let's see if that compiles. Yeah. Okay, and the reason I did that is so that I don't have to call a function to make a identity matrix. Here's my matrix. So this is all vertices, indices. Here we go. Yeah, so I don't have to call this create identity matrix. I can just, if I want an identity matrix, I can just pass in a 1 there. And then everything else should still be good. Execute. Yeah. Okay. All right. So now I need to do some rotations. I need to be able to rotate things. And to do that, I'm going to need a new type of structure, or a new union, I will say. That is a quaternion. And a quaternion is, I don't really know, to be honest. As far as I can describe it, it's like a 4D vector, but you just multiply them differently, and you can use a quaternion to convert it to a matrix. It just makes rotations easier, and it prevents things like gimbal lock. That's my dummy explanation of what a quaternion is. So yeah, you got an F32. I don't know what we call this, V. So it's basically 4 components, and then I want to be able to access them individually. So I have X, Y, a Z, and a W. Yeah, so I believe that's going to allow me to make a quaternion and then access the individual components. Let me just test that here. Q, if I want to say Q dot X equals -4. Everyone's happy with that, right? Yeah, okay. And then, so I'm going to also make a constructor for this, because I always want my quaternions, at least for now, to be initialized. I want X to be 0, Y 0, Z is 0, and the W will be 1. Get rid of that. And then what I'm going to do is I'm going to make a structure for a camera. So So struct camera, and my camera is going to have two matrices for now. It's going to have its projection, and then it's going to have its view. And we're going to build the view based off of some things here. So I'm going to make also a vector 3. That is also a 3-dimensional array, or not 3-dimensional array, array of 3 things. And then it's going to have a X, a Y, and a Z. And I don't want a, well, yeah, I'm going to go ahead and do this. So we got a default constructor that does nothing. We got a constructor that takes in one value and will just set the values of X, Y, and Z equal to that value. I probably shouldn't call that V since that's going to be V. I will call this. I don't know if I will call those. I'll call it array. It's not really accurate, but whatever. Yeah, then I want also the ability to take in an X, Y, and a Z. Actually, yeah, I forgot. It's all. I'm just gonna keep that as what it was. And so then we got X. Wait, actually, there's a better way to do this, right? We could do X. Is it colon? Is that right? No. What if I just get rid of that for now? What? Is it, oh, it's because I have a semicolon there? Is that why? No? Oh, it's because I didn't have a semicolon there. Yeah, so now I do need a semicolon there. All right. Cool, cool. Yeah, and now that's happy. So let me go ahead and just do that with the other one as well. All right, and I'm going to do that with this quaternion as well. Actually, want my W value to be 1. All right. So now what I need to do is be able to, okay, so I got my camera. Okay, so my camera is going to have also a position. It's going to have a forward vector. up vector and a vector that points to the camera's right. In addition to all those, it's going to have its own quaternion for an orientation. So I know which angle the camera's pointed at. I can get its position. I can figure out what direction it's going or pointing to. Yeah, so let's do this now. Let's make a constructor for my camera. I want, okay, so the view is just going to be a matrix for, that's the identity matrix for the start. Position, vector 3, just 0. The orientation, it's already initialized. And then forward is going to be vector 3, 0, 0, 1. Up is a vector 3 of 0, 1, 0. And vector 3 for the right points to the right. All right. And I'm eventually going to put this in its own file later. I just don't know where yet. Okay. Model matrix is good. Yeah, we're going to recalculate that here inside the loop. So transform matrix. All right, so instead of the projection matrix, we are going to have a camera. And then that will be the camera's projection is equal to that. And projection matrix 196. And 286. All right, so nothing should change there. Right, but now I am technically using my camera, so that's good. All right, so now when I'm doing this, I'm moving the model, which I shouldn't be doing. What I want to do is move the camera. So let's change this to camera.position. .z. So when I'm pressing W, I want to move the camera's Z position forward. I want to subtract from the Z when I'm pressing S. I want to, when I'm pressing A, I believe I want to subtract from the X, but I don't know. I'm going to leave it as that for now. And then, so I want to, anyway, A and D is going to move left and right, which is going to affect the X coordinate. So my transform matrix is the camera's projection multiplied by the model. But I need to actually add something else here. Oh yeah, you know what I'm going to do? I'm going to make a operator override, so that, or overload, so that I can multiply matrices using the star feature. And also what I'm going to do is I'm going to pass these in by reference, so that way I'm not, I think that will technically be faster because I'm just passing a memory address and not making a copy. Yeah, let's try that. I don't think that's going to affect anything. Yeah. Okay, so let's see here. We want a matrix for operator star. Here is matrix for M1, matrix for address on 2. And then all I want to do is return multiply of M1 and 2. Does that do it for me? Does that compile at least? Yeah. So let's test that. If I just do camera projection times the model matrix. Yeah. Okay. Okay, so now I think I can just take the camera view, multiply that in there as well, but I actually need to build the camera view. Yeah, it doesn't affect anything because that's just the identity matrix. All right, so now to build the camera view, I need to translate the view by the camera's position. So let's make a translate function. Void translate, and then it's going to take in a matrix to be translated, so taking as a pointer, and then a vector 3 to translate it by. And so I just want to be able to move the position of the matrix, which is the first column, wait, third row, 0. I was doing it over here. That's the Z, yeah, so 3, 2 is the Z, so 3, 0 would be the X. This equals V dot X. All right, so that should do that. And now I want to okay, so now the camera, actually, I'm going to translate the camera's view by the camera position. No, okay, so matrix, because it is a matrix 4. Whoa, that's a lot faster. What's going on here? Okay. Yeah, so I also want to handle what happens if I'm not pressing the key. Yeah, so this is basically, oh no, wait, no, actually what I want to do. Yeah, something's not right. Oh yeah, I want to reset the view every frame, I believe. And then this is in dire need of some optimization, obviously, but we'll get there. There we go. Okay. So now what I need is some other keys to press. Let's bring back some docs here. Go to the key codes. I want, here we go, up, down, left, and right. VK up, down, left, and right. So let's make some more keys. Let's define key up to be, oops, I don't need equals, VK up. Let's define key down to be VK down. All right, and just to test that those were working, let's check key inputs for VK up. Yeah, okay. Very thorough test I just did there. Okay, so now when I press the up and down arrows, I want the camera to pitch up and pitch down. So how do I do that? I need to rotate my quaternion. So okay, so what I need to be able to do is convert my quaternion, my camera's orientation, into a matrix so that I can multiply it by the view, and then it'll modify that view to represent that new angle. So let's go to the Google box here and type in quaternion to matrix. Yeah. Here we go. And then this is essentially the formula that I need right here, as far as I know. So let's do this here. I'm gonna make everything static. Okay. So static, it's gonna return a matrix 4. It's gonna be quaternion to matrix 4. It's going to take in a quaternion, and then it's going to make a matrix 4. Make everything 0, and then I'm going to eventually return that. But then first I need to build it up. So everything is here, and I do believe I need to transpose this. So these will be the columns and these will be the rows. So first one is 1 minus 2 times the quaternion's y squared minus 2 times the quaternion's z squared. So that would mean, oops, what am I doing? All right, m dot m0 is equal to 1 minus 2 times q dot y times q dot y minus, again, 2 times q dot z times q dot z, and slap another set of parens around this just to be happy. All right, 1 down, 15 to go. So now I want to go this way. So the matrix 1 is 2 times q dot x times q dot y plus 2 times q dot z times q dot w plus 2 times q dot z times q dot w, right? Q dot z, q dot w, yeah. All right, so next 2 times q dot x times q dot z, 2 times q dot x times q dot z, minus 2 times q dot w times q dot y times q dot w. And there is no fourth parameter there, so that's just going to be 0. All right, next, so m dot 4, 2 times q dot x times q dot y, 2 times q dot x times q dot y, minus 2 times q dot z times q dot w. Okay, now we're here. 1 minus 2 times q dot x times q dot x. That's going to be minus 2 times q dot z times q dot z. So then next, we got the 2 times q dot y times q dot z plus 2 times q dot x times q dot w. 7 is 0. All right, one more row to go. M.8 is 2 times q dot x times q dot z plus 2 times q dot y times q dot w. 2 times q dot y times q dot z minus 2 times q dot x times q dot w. Is that right? 2 times q dot y times q dot z, q dot x, q dot w. Okay, getting there. So now I'm here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, starting at 0. Okay. So this is 1 minus 2 times q dot x times q dot x minus 2 times q dot y times q dot y. And let's put some more parentheses here, and this one as well. Here, okay, so now I just need the last column. Actually, one more. 0, so that's that. Yeah, and then so everything else is 0, 0, 0, and last but not least is 1. Okay, so I probably fat fingered some of that and it's got some typos, but we'll find out soon enough. So I now have a quaternion to matrix 4. So what I want to be able to do is make a matrix for, that'll be my cam rotation, and then that's going to be equal to the quaternion to matrix 4, and I'm going to pass in the camera's orientation. And hopefully that'll do it. No compiler errors. So then I want camera.view to equal itself. Ooh, you know what? Let me do that later. So camera view times cam rotation. Okay, so that shouldn't affect anything at all. Nothing. Okay. But if I change the camera's orientation, so if I say camera dot orientation dot x plus equals 0.001, what is that going to do? It seems to be working. If I just say it's equal to 0.1, does that just set it stationary? Yeah, okay, so I want to increment it. All right, so now the test is if I do it faster, will it loop all the way back and come out the bottom? Doesn't look like it. Yeah, it just disappears, it looks like, unless I'm just not waiting long enough. Let's make it go faster. That just disappeared. Wait, plus equals. There it goes. Okay, but then why doesn't it come back? Do I have this wrong? I know order does matter when it comes to matrices. All right, so let's add some key inputs to be able to control the orientation, and that might be able to hook me up a little bit better. All right, so if key inputs for key up is pressed, then I want the camera dot orientation dot x to increase by that much. And then if I press the down arrow, I want it to go the opposite direction. Key down, undeclared identifier. You sure about that? Dandwa. All right, up, down. Okay, so that looks good, but the problem is I should have it come back around if I do a full circle, but it doesn't seem like that's happening, unless I'm just not being patient enough. Yeah, like it really just disappears on you. Okay, so now if I go the opposite way, will it come back? Sure doesn't seem like it. Okay, that would explain it. What the heck is going on here? Okay, yeah, I think the order in which I'm doing things is wrong. So yeah, that seems fine, unless... Do I have it all completely backwards? I doubt it. Yeah, see, now it's not even showing. Okay. Yeah, so that was not right. That's that. So maybe the view... it's also very possible that this is wrong too. Let me double check everything here. What? There we go. Okay. So 1 minus 2 times y squared minus 2 times z squared. Let's not do that. Maybe that's the problem. Now that looks right. Is that all it was? Okay, so if it comes back from the bottom, then I'm going to be happy. Still not coming back. Okay, so let's double check everything else. So 1 minus 2 times y squared minus 2 times z squared, 2 times x times y minus, wait, I'm going down. 2 times x times y plus 2 times z times w, 2 times q times z minus 2 times y times w, 0. 2 times x times y minus 2 times z times w, 1 minus 2 times x minus 2 times z times z, 2 times y times z plus 2 times x times w, 0, 2 times x times z plus 2 times y times w, 2 times y times z, 1 minus 2 times x squared minus 2 times y squared. Yeah, it's all looking good. And then 0, 0, 0, 1. What if I back way up? Will it give me a better sense of what is going on? Yeah. Okay, so it's still not right. Okay. But this does seem to be good, unless I wasn't supposed to transpose it. But I seriously doubt that, because everything else I get from this page is all transposed. Yeah, actually. Oh, you know what? I know what's going on. I want to actually do this prior to that, I think. So yeah, calculate the camera's rotation, translate the camera's position first, and then rotate it. I hope that works. Yeah, it's looking promising here. Or not. Nope. Okay. Let's go ahead and back up again, way up. Yeah, okay. Same thing. Okay, I don't really fix anything. Oh, something stupid. I know it's got to be. Let me flip this around again. Is it working now? Nope. This is annoying. Yeah, let me just try transposing this. I don't think that's the problem, but that's... It really seems like it should be working now. It just doesn't come out the other side. Oh, you know what? Also, what if, without any movement? Let me add one more set of keys here. 51 and 45. Okay, so I'm gonna add some spinning, basically. See if that works at all. No, not at all. Oh, because there's no QR, it's QE. That would be it. It should actually read my errors when they come up. Okay. So that, I'm not trying to move forward, I'm just trying to rotate, and then it's moving it forward. So yeah, clearly this isn't right. What am I missing? I'm missing something stupid, I know it. Something basic. Okay, so I take the quaternion. Oh yeah, so let's try transposing this. I gotta figure out how. So let's just let's change all this to 0, 0, 0. Oops, and that would be 1, 0, 1, 1, 1, 2, 1, 3, and then that would be 2, 0, 2, 1, 2, 2, 2, 3, and that'll be 3, 0, 3, 1, 3, 3, nope, 2, and 3, 3. And then I want all of this to be 2. So that shouldn't change anything. Yeah, all right, so now I can and it is basically doing the exact same thing. Yeah, nothing. Okay, so let's keep it as it was. And figure out why. Is it because my model, my model matrix, this really shouldn't affect that at all. Yeah, because that's just set somewhere. Let's just try this here. Yeah, so let's put that back at 0, and then set the camera's position dot z plus equals 1. There we go. And it's still messing it up. Why? Yeah, I'm gonna cheat a little bit. I'm gonna look at, I wrote this function before in a previous project I done, and I'm gonna look at that and see, just to make sure that at least that function is written correctly. And if it is, then I know the problem's something else. All right, so 1 minus 2 times. Yeah, everything's spot on as far as I can tell. So this function, actually, yeah, it doesn't really affect me. I just got parentheses around everything, but I seriously doubt that matters. Okay, I'm getting tired. It's getting late. I'm gonna just go ahead and wrap it up because I don't think I have the brain capacity to figure this out right now anyway. And like I said, it's something stupid. It's something minor. But I did get some progress made. I got some sort of camera rotation, despite how wrong it is. Yeah. So anyway, next time I'm gonna fix this, and then I'm going to actually get it so that the camera moves in the direction that it's pointing. Because if you notice, if I'm looking up and I press forward, I'm still kind of like going, I'm not going in the direction that the camera's pointing. It's like the camera's like, if that makes any sense. So yeah, I'm gonna fix that next time, and I don't know what else I'll get going on, but that's it. All right, thank you. See you next time.